Hello everyone, welcome to the mathematics of my channel. In this video we are going to solve this interesting integral from 0 to infinity arctan of x times cosine of x over x dx. Well, how to begin? Okay, first I'm going to take f of t is equal to integral from 0 to infinity arctan of x times t times cosine of x over x dx. Okay, then as the next step I'm going to differentiate with respect to t. So here we have f dash of t is equal to integral from 0 to infinity now cosine of x over x times now derivative of arctan of xt with respect to t. We know 1 over 1 plus x square times t square. Then according to chain rule we should multiply with the coefficient of t. So here x times dx. Now we know this x get cancelled. So as the next step here we have t square. So I'm going to take 1 over t square as a common factor and it's a constant. So we can take outside of the integral sign. So here 0 to infinity cosine of x over 1 over t square plus x square dx. Okay, now we have another interesting integral. I solved this integral from 0 to infinity cosine of bx over a square plus x square dx is equal to, we know, pi over 2 times a times e to the minus a times b. I will add the link in the description and also make a card so you can watch. So here now we know this integral, same type of integral. So we have here 1 over t square times here pi over 2 times a we know 1 over t. So here 1 over t times here e to the minus a we know minus 1 over t and b we know 1. Well, this t get cancelled. So we have pi over 2 times e to the minus 1 over t over t. Okay, then I'm going to integrate both sides with respect to t. So we can write here f of t is equal to 5 over 2 constant, and here I'm going to take the definite integral from 0 to t. I'm going to change the variable e to the minus 1 over a times dA. Okay, let us plug in 1. So f of 1 is equal to, we know f of 1 is equal to our integral arctan of x, integral from 0 to infinity arctan of x times cosine of x over x dx, and we know this is equal to pi over 2 integral from 0 to 1 e to the minus 1 over a times dA. To evaluate this integral, I am going to use a substitution. 1 over a is equal to u. Then if we differentiate, we know du is equal to minus 1 over a square dA. Then a we know 1 over a u. So here minus u square times dA. So we can plug in here pi over 2 integral. Now we should change the boundary when a approaches to 0. We know u approaches to infinity, a approaches to 1, u also approaches to 1, and here e to the minus 1 over a we know minus u over here a we know 1 over u. So 1 over u dA. Here we can isolate the dA we know minus 1 over u square times du. Now we know this u get cancelled. So we have pi over 2 then we can change upper limit and lower limit 1 to infinity. When we change the limit, this minus sign get cancelled, so we have e to the minus u over u times du. Okay, then let's recall the exponential integral function. We know ei of x, this is the special function on complex plane. We know this is equal to minus x to infinity e to the minus t over t dt. So we can write our integral is equal to, now here, minus pi over 2 ei of, here we have 1, so minus 1. Okay, this is the answer for this integral. If you like this type of videos, please subscribe this channel. Thank you for watching.